Nanti saya akan tanya lagi dalam soalan lain. Okay, simple path. What is a simple path? Okay, definition dia, a journey with vertex appears not more than once in the vertex sequence. Tak apa. Saya ringkaskan. Okay, simple path, nak senang ingat. Okay, tadi path tak boleh lalu edge banyak kali kan? Simple path cannot visit the same vertex more than once. Tak boleh more than one, tak boleh. More than once, tak boleh. Okay, tadi kalau path cannot visit the same edge twice ataupun more than once. Kalau simple path, you cannot visit the same vertex more than once ataupun twice. Okay, more than once lah. Okay, contoh kalau yang this one ialah simple path. Okay, D, E, F, B, A. Okay, dia simple path because semua vertex dia visit only once. Okay, D, E, F, B, A. Semua vertex dia lalu sekali sahaja. Dia tak lalu tak lalu pun vertex yang sama banyak kali. Tapi let's say this one F, E, D, E, F, B, A kan. Let's say saya tambah lagi satu. Saya tambah lagi satu dekat sini. Kan? Okay. It is not simple path kalau saya pergi sini. It is still a path but not simple path. Saya ulang semula. It is still a path but not simple path. Because kenapa dia path? Sebab semua edge dia lalu sekali saja. Kan? Semua edge dia lalu sekali. Kena faham konsep ni sebab nanti next class nak kena guna konsep path ni. Okay? So dia lalu edge yang berlainan sekali saja. Tapi dia bukan simple path. Walaupun dia masih lagi path. Tapi dia bukan simple path. Because apa? Because dia lalu vertex F ni 2 kali kan? Dah lalu sekali. And then lalu lagi sekali lagi. So 2 kali lalu dekat sini. 2 times visit vertex F. Cannot. It is not a simple path. You must know this concept. Nanti later nak kena guna. Okay, jelas tak faham terus tanya, tak clear, tak faham saya explain, please let me know lah. Just interrupt me. Okay Right. Yes?
Kalau contoh macam D, E, B, A, F.
Ulang. D, E, B.
D, E, B, A, F. Ini tu.
D, E, B, A, F. Okay. Dia ialah simple path. Tapi kalau nak kata path pun boleh. Tapi specific name dia simple path. Yang saya ulang balik tadi kawan you tanya. Sekejap, saya padam dulu. Simple path dia nama lain, dia sebenarnya nama khas untuk path yang tak lalu vertex banyak kali. Tapi kalau you nak kata dia path pun boleh, tak ada masalah lagi. Okay, contoh kawan you tanya tadi, from D to E to B to A tadi to A to F kan? Ini ialah path. Path, yes, it is a path. Okay, sebab dia lalu edge yang berbeza sekali. Dan dia juga simple path. Sebab dia lalu vertex yang berlainan. Pun dipanggil simple path. So you can say it is a path pun boleh, simple path pun boleh. Boleh, tak ada masalah. Tapi kalau tiba-tiba you pergi balik dekat B, dah bukan simple path lah. Tapi dia masih lagi simple. Dia masih lagi path. Tapi bukan simple path sebab dia lalu B tu 2 kali. Lepas tu tiba-tiba pula awak pergi kat B, E balik. Ni dah memang bukan path. Bukan simple path, bukan path. Sebab apa? You are using this edge twice. Kan, yang ni pun dah 2 kali guna. So tak boleh lah, maksudnya dia bukan path langsung. Bukan path, bukan simple path. Okay, clear konsep dia tu? Sebab nak kena guna ni, kena faham konsep. Okay, alright, faham Teruskan, saya teruskanlah kalau tak ada soalan lain. Yang penting faham betul-betul konsep ni. Nanti nak kena guna. Kalau tak faham konsep tu, aduh, saya nak explain later pun lagi penat. Alright, tadi simple path. This one is simple graph. Okay, tadi simple path kan, this is simple graph. The definition of simple graph is no multiple edges, no loop. Memorize it now. No multiple edges, no loop. Tadi dah explain dah what is multiple edges, what is a loop. Dah explain tadi dah. So, how far? Simple graph, no multiple edges, no loop. Okay. Yang ini nampak bulat macam loop kan? Tak. Sebenarnya dia dot lah ni. Cuma dia lukisan dia tu dia tak hitam kan. Jangan confuse dia bukan loop. Dia ialah dot. Okay So dia vertex. Okay. So dekat dalam graph ni, there is no multiple edges, there is no loop. So we call it as a simple graph. Okay, hafal hafal sekarang hafal 5 saat. 1, 2, 3, 4, 5. Okay, habis hafal dah hafal. Okay, next. Multi-graph. Okay, multi-graph tu maksudnya apa? Multi-graph pula, ada multiple edges but no loops. Okay, multiple edges tu kat mana? Ni lah dia, multiple edges. Okay, saya tanya, saya jawab. Okay, ni multiple edges. Okay, so inilah multiple edges. Kenapa? Sebab two edges share with the same vertices. Ni ialah multiple edges. So dia tak ada loop tapi ada multiple edges. Nama khas dia multi-graph. Okay, alright, clear. Kalau pseudograph, dua-dua dia ada. Multiple edges pun ada, loop pun dia ada. So dia ialah pseudograph. Kat mana multiple edges? Kat sini. Saya jawab lagi. Oh tak apa. Saya jawab kat sini. Okay. Kat mana loop? Ni loop. So meaning that dua-dua dia ada. Multiple edges ada, loop pun dia ada. So we call it as a pseudograph. Yeah. Tak apa, ni semua terminologis. Okay, tak penting sangat. Okay. Directed graph tu apa pula? Directed graph ialah all edges have arrow. Ada arrow lah. So nampak tak? Semua edge ni dia ada arrow. We call it as a directed graph. Because of if you are trying to come up with the ordered pair of the edges, kalau you salah direction, dia salah. Because of arrow tu meaning that you have a direction. Let's say I name this vertex A, I name this vertex B. So if you ask to write down the edge, you must write down like this, A, B. Baru betul. Dan tak boleh write down BA. Salah, tak sama. Because BA tu dia mesti ada arrow. Arrow tu from B to A lah. You must write down A, B because we have arrow. So every arrow ni ialah dipanggil directed graph kalau dia ada arrow. Clear? Senang je nak ingat. Ada arrow tu namanya directed graph. Ada nama khas dia. Kalau tak ada arrow, namanya undirected graph. Okay, meaning that kalau you are being asking to write down the name of the edge, kalau you nak tulis AB pun boleh, kalau you nak tulis BA pun boleh. It's up to you, boleh diterima because there is no direction, because there is no arrow. So you want to write down AB, BA, it is acceptable lah. Alright, clear? Ini semua terminologi lah, tak ada masalah pun. Weighted graph. What is a weighted graph? All edges have been labeled with numbers. Itu dia punya key point dia. Meaning that you can see that all the edges inside in this graph is labeling with the numbers. So we call it as a weighted graph. Ada nama khas dia. You will be seeing this kind of graph later in the subtopic trees. Akan banyak guna dekat minimal spanning tree. Memang akan banyak jumpa bentuk graph macam ni. So if the graph is labeled with number accordingly to the edges, so we call it as a weighted graph. Okay, semua tu term-term sajalah, boring lah. Okay. Connected graph, there is a path of edges between every pair of vertices in the graph. Maksudnya dia connected lah, connected. Dia tak ada pun terputus antara dua-dua graph ni. So dia ada connected kat sini. So dia panggil connected graph. Okay, kalau dia not connected graph, dipanggil disconnected graph. No path between at least two vertices. Tengok ini dengan dot ni, dia tak bersambung. So dia tak bersambung, dia disconnected graph lah. So we call it as a this component. This one is part is one component, and then this one pun one component. Okay, we have two components here because it's not connected to each other. Okay, we call it as a disconnected graph. Clear? Okay, dia semua nama-nama ni kena ambil tahu lah. Yang ni tak penting sangat, just ambil tahu. Kod-kod dia keluar dekat final, you know how to do it. Okay, example one, I will not show you example one sebab example one tu dalam YouTube you boleh tengok. Okay. So saya skip example one. You can see it later. Bila free, pergi kat YouTube, tengoklah example one tu. I just want to show you example tu terus dekat dalam nota tu ada example tu kan. Okay, saya akan terangkan example tu. Saya tanya balik nanti, tolong jawablah respon saya tanya, respon. Sebab saya dah explain tadi teori. Okay, example tu, okay, based on the following weighted graph. Okay, weighted graph ni lah. Sebab apa weighted graph? Sebab dia nombor kan. Okay, answer the following question. Okay, first ialah dia suruh cari find the number. The number tu bilangan lah, the number of vertices. Okay, so vertices tu ialah tadi yang dot-dot tu kan. So you kira ada berapa vertices kat sini. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Semua dot-dot tu ada 10. So the number of the number of vertices is 10. So jawapan 10. Boleh jelas Okay. Find the number of edges. So edges tu semua garisan ataupun line yang connected to every vertex. So kiralah ada berapa edge. Ni semua edge ni simple je. Saya tak tanyalah. Okay, simple kan. Simple je sebab di edge. So kira ada berapa? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, semua ada 11 garisan, 11 lines. So we call it as an edge. So the answer is 11. Okay, clear Alright. Okay, so find the degree of each vertex. Dia nak degree for each vertex. So you have to write down like this lah. Dia guna huruf kecil besar. Okay, kan? So you kena buat lah macam ni. A ada berapa? B apa degree dia? C degree dia berapa? D degree berapa dan seterusnya lah. Tapi saya lukis, I write down the answer in the graph. Okay, so look at A. So kira berapakah degree A? Someone let me know. Degree A berapa?
3.
Very good. 3 kan? 1, 2, 3, 3. So B degree-nya 2, C degree-nya 1, 2, 3, 4, D degree kosong, J kosong, E 3, 4 ialah F ialah degree 2, G degree-nya 0, H 1, 2, 3, 4, and then I 1, 2, 3, 4, 5. So itulah dia nama degree. Nanti dekat dalam jawapan tu you must write down like this lah. A berapa, B berapa sampailah IJ semua tu. Itu dah degree. From now on you must know how to count the degree. Kena tahu how to kira, how to count because we will be using this tomorrow. Okay Okay, so then degree settle. Find the isolated vertex. Isolated vertex degree bernilai berapa?
Kosong.
Kosong, very good. So ada 3 lah, J, G, D. Kalau satu markah, kena tulis semua. Kalau tertinggal satu vertex tu kosong lah markah awak. Dia mesti kata find the satu vertex tu dia kena semua lah. Okay. Okay, tandem vertex degree berapa?
1.
1, very good. Dalam graf ni tak ada pun degree bernilai 1. So tak ada lah. So boleh buat 9. Okay, kacang bonceh sahaja. Senang kan? Okay. The size of the graph tadi sama dengan apa?
Wait.
Yes, dia sama dengan vertices kan? So kira tadi dah kira dah tadi. Number of vertices 10. So size pun 10. Senang je. Okay, boleh What is the loop vertex? Dalam graf ni ada loop tak? Cari ada loop?
Tak
Tak
ada.
ada. Okay, good. So, dia tak ada. So, tak ada loop, letaklah 9. Tak ada. Ataupun not exist pun boleh. Okay, what are the multiple edges? Okay, let me know. Which one is the multiple edges? Ada tak? Cari.
HI tu
Very good. HI. And then IH. Ada 2 lah. Maksudnya dia ada HI, IH. So inilah multiple edges. Very good. So you can write down your answer like this. HI and IH. Ni pun satu markah lah. Kalau dalam keluar kalau dalam final keluar dia akan satu markah. Okay. Length ni saya memang tak mention. Saya tak ajar pun length tadi. Length saya tak ajar. Memang tak ada dalam slide. So actually what is length? Okay, awak kena hafal lah length tu apa. So saya memang tak ada dalam slide. So kena ambil take note kat sini. Length is actually the sum of weighted graph. Okay, so the weighted graph tu ada nombor-nombor kan? Awak tambahkan semua. Tu dia panggil length. Okay. Tambahkan semua nombor-nombor tu dia panggil length. Okay, tambahkanlah. Okay, 3, okay, 3, 4, 5, 6, 7, 11, 12, 15, 15, 17, 18, 19, 20. So semua tu tambah total up the answer is 20. So actually it is length. Tambahkan saja. Tambahkan semua nombor tu length. Okay. Okay, is this a simple graph? If it is not, give a reason. Okay, is this a simple graph? Yes or no? Jawab. Saya dah explain tadi.
No.
Very good. Okay, no dia bukan simple graph. No, it is not a simple graph. Okay, bagi reason. Tadi kita dah tengok dah ada multiple edges kan? Okay, no because it has multiple edges. Itu jawapan dia. Sebab kalau simple graph, dia punya definition dia no multiple edges, no loop. Tapi dalam graph tu ada multiple edges. So it is not a simple graph. Kalau ada multiple edges saja, dia ada nama tak? Tadi multigraph ada nama. Hmm, ah, multigraph. Kalau itu multigraph. Yang ni bukan simple graph. Graph ni dah nama multigraph. Sebab multigraph ada multiple edges tapi tak ada loop. This one is multiple graph. Multigraph. Okay. Is this a connected graph? If it is not, give a reason. Connected ke? Yes ke no?
No.
No, very good. So kalau nak bagi reason, boleh bagi tahulah because JGD is not connected to other vertices. Okay, so it is not connected graph. No, because JGD is not connected. It's not connected to other vertices. Protect your important folders. Protect your document desktop and pictures folders in OneDrive so you can access them from other devices. Okay, tak faham. Dah abaikan. Okay. So, itu maksud dia lah because JGD tu tadi is not connected to other vertices. So, dia bukan connected graph. Okay, state whether ACEFB is a path or not. If it is not, give a reason. Okay, dia kata path. Just now I already explained to you the meaning of path. So actually path tu, saya ulang semula, path, you cannot visit the same apa? Edge ke vertex?
H.
Bagus, pandai. Okay, dah boleh masuk final dah. Okay, kalau path tak boleh lalu edge yang sama banyak kali. So dia tanya adakah dia bagi sequence tu path ke tak. Okay, dia bagi sequence A, C, E, F, B. So A to C. Okay, dia kata adakah A, C, E, F, B F, B. Is it a path? Okay, so saya buat arrow lah, arrow kat sini. So yes or no? Yes or no? Path ke tak path? Anyone? Anyone? Tak apa, try je. Salah tak apa.
Yes.
Yes, very good. Sebab apa? Sebab dia memang lalu edge yang berlainan kan? Tak lalu pun the same edge. So memang dia ialah path. Dan dia pun simple path sebenarnya. Sebab dia lalu vertex yang berlainan, edge yang berlainan pun boleh jadi simple path. Tapi soalan kata path saja kan? So yes lah. So no need to give reason. Kalau dia kata is not kan? Kalau nak berbual juga yes because it visit the different edge. Ataupun yes because it not visit the same edge twice pun boleh. Okay. So state whether blah 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 is a path or not. Masih lagi path. Okay, saya badan balik. Okay, then dia kata HIC. KHI. KHIC. Lepas tu pergi ke E. And then to A. Lepas tu to E. Okay, lalu sini 2 kali. Okay, so from here. So is it a path?
No.
No. Bagi reason?
Sebab dia lalu tempat yang sama.
Yes, very good. Tempat tu you tukar jadi H. Okay, sebab H ni, HAE ni. HAE ni 2 kali lalu. Okay, tak boleh. So, the answer is no. So, then you kena bagi reason because it visit tadi HAE twice. Ataupun any explanation. Okay, acceptable. Okay, as long as I can understand it. Okay, so just give your reason by using your own words lah. Okay, the next one, state whether FBI blah 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 is a simple path. Okay, so recall balik what is a simple path. Simple path is a path that not using the same vertices twice. Okay, itu simple path. Kalau path H, simple path fokus kepada vertex. Okay, FBI. So from F to B to I. Okay, FBI, HIB. HIB. Okay, so dia punya arrow dia macam ni lah. Macam ni, macam ni. Macam ni, macam ni. Lepas tu pergi ke sini balik. So if you notice here, from F to B ni, and then pergi ke I. Lepas tu dia pergi ke H, pergi ke I. So I ni dah lalu 2 kali. And then patah balik dekat B. So B pun lalu 2 kali. So dia lalu vertex yang sama twice. Tak boleh lah. So it's not a simple path. Dan dia bukan path pun sebab lalu the same age twice. Okay. So itu reason dia. So you can say that it is not a simple path. Okay, bagi reason because it visit vertex B and I. Okay, because it visits vertex. Sorry, tulisan buruk. B and I twice. Okay, or you can use your own words lah to explain. Saya accept saja. Clear Okay, tak faham tanya terus. Okay, state whether blah 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 is a circuit or not. Okay, recall balik circuit begins and ends at the same vertex. Obviously lah memang tahu dari circuit sebab dia nampak ni. E, start kat E, habis kat E. Kan? Tapi tak apa, I show you. Okay, bagi senang faham lagi. Okay, so E, F. Okay, start from E, go to F, and then go to B, go to I, go to C, go to E. Okay, so you notice here, I start from E and then go back to E again. Okay, so dia start dekat E dan habis kat E. So dia pusing lalu kat E balik. So that is a circuit. Yes. Kalau dikata bagi reason juga, yes, because it start and ends at the same vertex. Okay, so dan dia pun tak ada pun lalu H banyak kali. So dia circuit lah. Let's say soalan ni dia katalah dah habis kat sini, dia pergi dekat sini pula. Dia pergi ke C and then dia patah balik dekat E. Okay, nampak macam circuit kan? Sebab dia dah pergi sini, pergi sini, patah balik kat sini. Patah balik kat sini. Yes, betul. Dia circuit sebab dia start I tempat sama tapi dia bukan pass lah. Maksudnya tak jadi circuit. Sebab tapi dia bukan pass. Dia circuit tapi dia bukan pass. Sebab pass dia lalu ni, lalu age yang sama banyak kali tak boleh. Dia circuit tapi dia bukan pass. So kena faham betul-betul konsep path, simple path, circuit. Okay, that is for example 2. Okay, setakat ini ada soalan ke tara?
Tak ada pun.
Okay, so good. Hopefully yang lain tak respond tu, I assume you understand lah because you are not responding to me. So hopefully you understand it. Okay, the next part I want to teach you is the types of graph. Okay, boring sikit lah hari ni sebab dia banyak benda nak kena explain, theoretical part banyak. But you must memorize it. Okay, so later you will learn about different types of graph and then you must know the planarity in graph and isomorphic graph. So saya akan ada 3 part ni lah. So please bertahan dengan saya a few minutes more. Boring sikit because tak ada kiraan. No calculation. It's quite boring. Okay, please bear with me ya. Tahan sikit lagi. Okay, then we go to the first part. Wow, dia terbang. Okay, the different types of graph. Okay, the first one you must memorize this name. This name is discrete graph. The definition is no edges. So this is the way how the discrete graph will be look like. Okay, no edges, just vertex only. No edges, no line between two vertices. So ni lah panggil discrete. Clear? Dalam soalan saya tanya, draw ataupun sketch the discrete graph for D5. Dia nanti saya terangkan kemudian. Next, complete graph. Okay, tak faham ni pun tak apa. Yang penting faham konsep dia. Complete graph, all vertices must be connected to each other. Okay, complete graph is all the vertices must connected to each other. Contoh, yang number 1, 2, 3, 4, 5 ni semua ni, itu maksudnya ialah the number of vertices. K1, 2, 3, 4. Maksudnya K1 ada satu vertex saja. Tapi tak, satu vertex ni maksudnya macam tu je lah. Kalau K2 ada 2 vertex, so they connect to each other. Kalau K3, we have 3 vertices and the vertices connect to each other. Kalau K4 pun sama, so all the vertices connected to each other with the edges. K5, we have 5 vertices pun connected to each other. Kena buatlah, kena connectkan everything sama dengan K7, K6. 7, 8, 9 dan seterusnya pun mesti kena tunjuk how you connected the vertices among each other tu kena tunjuk. Kalau dia 7 ke 8, 9 vertices. So dia panggil complete graph. Okay. Biasa soalan dia suruh lukis. Okay. Next, linear graph. As you know, you heard about linear graph so many times before this. What is a linear graph? Actually, it's a straight line lah. Okay, you already know how to draw ataupun sketch the linear graph by using the equation kan, y equals to mc plus mx plus c, dulu belajar kan. So dia linear graph lah. Linear graph tu simple lah, straight line. Either horizontally, vertically or diagonally. So boleh buat dalam bentuk horizontal, vertical, diagonal like this or diagonal like this, is okay. It's up to you, but as long as it is curved. If you draw like this, bentuk S macam ni, macam mula ni, so salah lah. It's not a straight line. Kalau you nak buat line zigzag also, incorrect. Okay, because it's not a straight line. So you must draw straight line. Baru dapat markah. Kalau tak, no full mark. Okay, clear eh? Okay, by petak graph ni later, I will show you later. Okay. Q. Okay, tak apa saya terangkan kemudian. Ni pun saya terangkan kemudian. Okay, what is a complete bipetak graph? Okay, actually bipetak graph ni dia ada two ways how to draw it. Left to right or up to down. Okay, I ulang balik, ada two ways to draw ataupun to sketch. From left to right ataupun up to down. It's up to you. Okay, K2 meaning that we have 2 vertices here. Kalau K3 meaning that we have 3 vertices here. Kalau you nak buat dalam bentuk left and right, so meaning that 2 kat sini and then 3 at the right side. Tu maksud berpetak graph lah. And then dia kata complete. Sekejap, saya punya ni lah. Wait. Okay, dia kata complete meaning that sama juga macam complete graph juga dia punya apa tu konsep dia. You have to connect to each vertices. Itu masuk complete. So from left to right ataupun up to down tu, you must connect lah, connect to every vertices. Saya akan tunjukkan kemudian. Okay, itu konsep different types of graph. Okay, tak faham, don't worry, I'll show you example. So example 3 saya akan skip sebab dalam ni dekat YouTube ada. Okay, saya skip example 3. So saya akan explain dekat example 4. Okay, example 4 dalam nota. Okay, example 4 dalam nota. Okay, look at here, example 4 in your graph, in your notes, example 4, tak ada dalam video. Okay, so you can notice here, you will have numbers, kan? D3, L3, K6, K2, 5. So all the numbers actually is related to the number of vertices. Okay, saya ulang semula. All the numbers refer to the number of vertices. Okay, so the question asks you to draw the following graph lah. Discrete graph D6. Kalau D6, 6 tu maksudnya 6 vertices. Okay, so lukislah randomly. Just draw 6 dot ataupun 6 vertices like this. It can be any shape lah. Okay, you can put the dot anywhere you like as long as it is 6. Biasanya 2 markah lah. Kalau terkurang terlebih tak boleh. Dia mesti cukup 6 vertex. Clear eh? So don't draw the line because discrete graph only have vertices, no edges. Clear eh? Tak faham terus tanya. Okay, tengok pula kat sini linear. Kata linear, L3 meaning that 3 vertex. Linear graph is straight line. It's up to you. Horizontal ke, vertical ke, diagonal ke, janji dia straight line. So I will draw these 3 vertices and then just draw a straight line here. Okay, itu dipanggil linear graph. Clear eh? Okay, the next one is complete graph. Okay, tadi saya dah tunjuk complete graph K6. K6 so 6 vertex. K6 vertices. So suka Tina nak bentuk macam mana? Saya suka buat bentuk macam ni so that kita boleh senang nak connect. Okay, so then how to draw the complete graph? Okay, complete graph you have how you want to draw. I just connect every vertices, connect je, connect to each other. Okay, lepas tu ni pun connect. Semua kena connect to each other lah. Okay, alright macam ni, okay. And then this one, okay ada lagi tak? Rasa dah cukup dah. Okay, so semua dah ada. Okay, connect to each other. Ini dipanggil complete graph, clear Dan kalau tertinggal satu line pun, terlupa nak connect, memang salah. Kalau dua markah, tengok nampak tertinggal. So this one, ni tertinggal yang ini. Okay, yang ni ialah complete graph. Okay, nampak macam betul tadi tapi salah. Tertinggal satu graph. Okay, clear. Settle. Tak faham terus tanya. Complete bipartite graph. Tadi saya dah explain apa itu bipartite. Okay, complete. Dia nak complete. So K25. So let's say saya nak buat left to right. So 2 tu located at the left side. 5 located at the right side. Yeah, right hand side. Okay, then you just draw like this. Just connect the dot. Okay, kiri dan kanan, left and right. Just connect like this. Okay, also like this also. Okay, draw like this. Okay, finish. Okay, this is a complete bipartite graph. Or you can draw up down lah. Sini pun boleh juga. Pun boleh. Ikutlah kalau nak yang macam mana. Janji betul. Okay, connect and then connect to every vertices. Okay, clear boleh kiri kanan, up and down. Okay, ada soalan ke? Tak ada. For number 1.
Tak ada.
Good. Okay, draw a bipartite graph for the following. Okay, this one dia suruh lukis bipartite graph. Bipartite graph tadi saya dah explain dah. Left, right boleh, up, down pun boleh. So how to draw? Okay, senang saja. Ini saya tak terangkan dalam slide. Baru nak tunjuk. Okay, so we have the graph here. You have to convert to bipartite graph. Okay, convert to bipartite graph. Okay, you can start from any vertex, A, B, C, D or F. You can start with any vertex. But let's say I start with A. Okay, so I put A here. I write down the A here. And then tengok dia connect dengan siapa. Dia connect dengan B, dia connect dengan F. So kena buat opposite lah. A to F, A to B, A to F. Macam ni, senang je. Yeah. So buat connection tu dekat opposite side. Okay, settle A. Tengok B pula. B connect with A, connect with C. So BA dah ada, so letak C. C dekat opposite lah, BC. Clear senang. Yang C pula connect to B, connect to D. So CB dah buat and then connect with D, write down to the opposite side. Okay, clear. So D connect to C, connect to E. So CD dah ada, so CE pula. So C to E, letak kat sini E. DC. Sorry. Saya dah merepek dah. Merepek. D connect to C, connect to E. DC dah ada, so E. So E tu buat dekat opposite side. Okay. So and then E connect to D, connect to F. So ED dah ada, EF lah, EF. So F tadi A dengan E dah buat dah, A dengan E dah ada. So this is the bipartite graph. Okay. So nak tahu dia betul ke tak betul ialah kalau semua connected tu, semua point ni ataupun semua vertex tu different from the left and right side, different. Let's say kalau you lukis, contoh you buat lukis A pergi ke B, and then B pergi ke C, and then contohlah contoh apa tu F, lepas tu A pula. A macam ni. Okay. Kalau you lukis macam ni and then terpaksa lukis macam ni, maksudnya you kena lukis bentuk macam ni. Maksudnya ada dua vertex yang sama dekat the same side, so dia bukan bipartite graph. Not a bipartite graph. Okay. Dia tak boleh tak boleh ada tak boleh ada wait bukan macam ni bukan macam ni. Bukan macam ni. Let's say C ni sorry katalah C tu connect to A. You tak boleh lukis macam ni, tak boleh. You kena buat C A kan. So A tu berada di satu tempat, tak boleh. Dia mesti satu huruf satu tempat je, left or right. So let's say you connect from C to A dan A ni ada dekat sebelah kiri, A pun ada dekat sebelah kanan. Dia bukan berapa type graph. Okay, the same variable cannot have both side, at both side cannot. Tu masuk berapa type. Okay clear tapi jaranglah keluar soalan macam ni. Kalau keluar pun, kalau you show that like this, just mention conclusion not a bipartite graph. Okay, sebab dia ada the same variable at both side. Cannot. Okay, clear Simple, kacang buncis saja. Okay, so saya proceed. Okay, saya proceed planarity. Okay, nanti awak tengok dekat video, nanti dia ada banyak contoh. Ada 2 contoh nak lukis bipartite graph ni. Nanti tengoklah contoh dia. Okay, so tengok this one. Okay, the second part ialah planarity in graph. Boring penat saya pun dah rasa letih dah cakap. Rasa macam haus tekak. Okay, a graph is called planar if it can be redrawn. It can be redrawn, lukis balik in the plane without any edges crossing. Maksudnya tak boleh bertindih, tak ada intersection point, tak ada pertindihan lah maksudnya, tak boleh nak cross. So kalau you boleh lukis, meaning that you are drawing the planar graph. Okay, if you cannot draw the graph without crossing the lines, meaning that the graph is not planar. Okay, contoh. Let's say this is the graph. It is not planar graph because of what? Dia ada cross section kat sini kan, ada intersect point kan, tak boleh. So dia ada intersection point kat sini, tak boleh lah, maksudnya it's not planar graph. You must make this graph become a planar graph by redrawing it ataupun lukis balik lah. So then how to draw? Okay, first lukis balik semua titik ataupun vertex. Bila you lukis balik, you kena follow all the location tak, all the old graph tu kena follow balik. Tak boleh lah awak tiba-tiba buat shape lain. Tiba-tiba you buat shape dia bentuk macam ni. Memanglah betul dia ialah 4 vertex tapi bentuknya dah lain. Tak sama pun. Kan macam bentuk diamond. Tak boleh lah. Kena follow the same graph. Cuma dia cuma akan different untuk tak jadikan dia planar saja. Okay. And then saya kekalkan garisan ni. Okay, kekalkan garisan ni. Okay, and then I stay with this line and I stay with this line. And I stay with this line lah. Okay. So meaning that yang crossing line ni, garisan ni yang kita nak ubah. We have to move this line to the other side. Okay, you can move like this. Okay, ataupun nak move macam ni pun boleh. Tak kisah. So you tarik dia keluar. So meaning that the new graph, there is no crossing line anymore. So this is a planar graph. Okay, this is a planar graph. Okay, contoh lagi. Example 5 saya bagi jawapan terus lah. So dia suruh lukis sama ada this one ialah boleh lukis planar graph ke tak. Okay, bila you lukis, okay, you lukis dia punya line-line dia and then you kena lukis balik line yang you nak kekalkan. Cuma you nak tukar. So this one dia removekan this line, dia bawa tarik keluar. Don't forget bila you tarikkan dia keluar tu, you must use the same vertex. So mesti macam ni lah. Tak boleh lah tiba-tiba you nak buat macam ni. Salah lah. Sebab dia ni dengan this one. You must use the same vertex. That's why jawapan dia bentuk macam tu. So this is planar. Tengok soalan B. So kalau you try to draw the planar graph, okay, you nak maksudnya sebenarnya kat sini intersection, ini pun ada intersection point kan. Dia crossing line kat situ kan. Okay, and then you try juga buat, tapi you try pun sampai mati pun sampai kiamat masih lagi ada crossing line. Kalau you try lah, kalau you rajin you try buat. Okay, you try buat soalan ni, you ubah macam mana lah pun, you try to redraw, you try to move any lines, but still you will get the crossing line. So it is not a planar. Not planar graph, okay? Sometimes the question will ask you, determine whether the following graph is planar or not, and then you must show that it is planar or not planar by redraw the graph. Okay, kalau you can draw without the crossing lines, it's a planar. Kalau you draw with the crossing line, so meaning that it's not planar. Okay, clear? Senang kacang buntir saja. So, saya skip example 5 tu dah tunjuk kan? Okay, saya masuk dekat, saya masuk contoh Contoh example 6 dekat dalam nota. Okay, identify the planarity of the following by constructing the planar graph. Okay, tengok dekat soalan ni. Okay, soalan ni crossing line tu kat sini, dekat sini, dekat sini. Ada 3 crossing line. I need to redraw it so that it will become planar graph lah. Okay, so saya staykan all the line and then saya kekalkan this line. Okay, ni cara nak lukis lah. And then mungkin orang lain cara lain, but it's up to you as long as you can show that it's a planar graph. Okay, so then I kekalkan this line. Okay, saya kekalkan this line. Saya nak remove this line only. Okay, saya remove lah. So by using this vertex and by using this vertex, saya remove line ni keluar. So saya keluarkan dia. So saya removekan line ni keluar. So saya keluarkan dia. So it is a planar graph because I can draw it again without crossing line. So it's a planar graph. Tak faham lagi, don't worry. Let show you next example. Okay, sama juga you are maintaining all the vertex with the same location. Let's say, okay, we have 1, 2, 3 crossing line there ataupun intersection point. Okay, let's say I want to remove this line and I want to remove this line. So meaning that I'm maintaining the other line lah. Okay, so saya maintain this line, I'll maintain this line. So saya maintain this line. Okay, line ni saya remove by using this vertex, saya buat keluar. So like this. Okay, I remove this line by maintaining these 2 vertices. So saya buat keluar dia. So like this. So dah tak ada lagi crossing line. So it will become planar. Clear boring sikit lah sebab senang. Senang sangat boring. Okay, dapat dah jadi planar. Okay, saya maintainkan all the lines. Clear. Tak faham terus tanya. Okay, saya teruskan lagi. Example, sama jugalah macam ni. Okay, so dia ada crossing line kat sini. So let's say saya nak removekan line ni. Okay, so saya pun kekalkan, saya maintain all the vertex and then saya maintainkan all the lines there ataupun edges. Okay, saya maintainkan. Saya nak removekan this straight line, so saya boleh bawa keluar. So dah jadilah planar. Kan senang saja. Ni jadi asal buruk gila macam itulah lebih kurang. Okay, ni planar. Okay, clear Okay, kat sini pula ada crossing line. Let's say saya nak buang, nak removekan line ni, saya nak removekan line ni. Okay, so again, use the same vertices and then maintaining all the unmoved line. So saya tak ada pun removekan apa-apa and then saya kekalkan saja. Okay, so then this line saya, ni line saya nak ni. Saya kekalkan, yang saya kekalkan ni. Okay, line ni saya remove ke sini. So line ni saya remove ke sana, okay. So dapatlah planar. So dia tak ada pun intersect dah. Okay, it will become planar graph. Okay. Clear alright. So hopefully you understand. Yes.
Yang macam soalan A tadi kan?
Saya salah lukis tu.
Tak. Saya nak tanya kalau dua line yang remove tu kan, kita tukar macam draw jadi segitiga kat atas boleh tak?
Oh, segitiga macam mana nak tukis? Segitiga macam ni?
Tak, kita connect point.
Saya nak buat macam ni. Macam mana?
Kita connect
ni.
point kat
Macam
atas
ni.
point kat atas.
Point ke atas.
Mai kat point yang satu ni. Buat macam
Ah.
segitiga ni.
Buat macam segitiga. Macam mana tu?
Kita sambung connect je lah.
Sambung macam mana? Nak sambung macam ni kena macam ni kan?
Oh dia tak boleh macam buat macam sambung connect dari first point ke second point, third point, fourth point, tak boleh macam tu
Dia kena ikut the same point. Tengok yang ini kan line ni. Line ni kan using these vertices kan? So dia kena guna the same vertices. So macam nak connect. Kalau straight line kan tak boleh. Dia kena ikut lah. Kalau you lukis macam ni, let's say you lukis bentuk ni. Salah lah sebab you are using the different vertex. Faham tak?
Faham.
So you must follow the same vertices. That's why kena buat macam ni. Kalau you connect with different vertices dah salah because you are actually ubah dan change the graph itself. Tak boleh. Kena guna the same vertices. Okay, so itulah pelana. Senang je kalau markah pun 2 markah biasanya, tak banyak pun. Okay, clear pelana boring lah sebab senang sangat. Okay, the last part. Saya pun dah kehausan dah. Ya Allah, puasa, sabarkanlah diriku ini, ya Allah. Okay, the last one lah, the last one. Saya ada kursus sebenarnya ni, tak usah kursus lagi. Aduh, kursus pun ponteng tadi. Okay, isomorphic Okay, isomorphic graph. I don't want to show this part. I just want to emphasize this part lah. Kan? Dia ialah mesti must have the same number of vertices, must have the same number of edges, must have the same number of degree. Hafal ni. So we call it as invariant. Okay, so apakah itu isomorphic? Inilah dia. You have to compare between two graph and then check all these element ataupun these properties ataupun these invariants. So then kalau semua sama, meaning that is isomorphic. Contoh, okay, saya skip example ni, you tengok dekat dalam YouTube. Saya akan masuk example 8 terus. Okay, example 8 dalam buku nota. Okay, example 7 tengok kat YouTube tengok sendiri. Okay, show that whether the graph is isomorphic or not. Okay, we have two graph here, G and H. So you have to compare each other. So isomorphic, you must memorize. It must have same the number of vertices, must have same numbers of edges, and must same the number of degree. Kena hafal. Ni dipanggil invariant ataupun properties lah. Properties ke invariant ke ikutlah isomorphic. Nama canggih isomorphic, tak ada apa pun. Okay, kena compare with these two invariants so then you can make conclusion whether it is isomorphic or not isomorphic. Actually, I like to draw a simple graph. Bukan simple graph, a simple table. Nak comparekan antara dua ni. Saya suka buat table bodoh-bodoh je lah macam ni kan. Okay, so saya namakan ni G and then this one H lah. For graph G, for graph H. So dekat this part, saya comparekan dia by vertices, okay, by edges and then by degree. Okay, so dekat sama juga dengan soalan B ni. Okay, saya buat siap-siap lah. Okay. GH, hausnya ya Allah ya Tuhanku. Kenapakah saya diduga begini? Cakap banyak kan masa dalam puasa cakap banyak. Wah, dugaan betul lah. Macam mana lah orang yang menyanyi lah, yang bagi ceramah tu lah, hebat lah. Banyak pahala dia. Okay, so kita check one by one. Okay, look at graph G. Count the number of vertices. Kira ada 1, 2, 3, 4, 5, 6. So ada 6 vertices. Kira edges. 1, 2, 3, 4, 5, 6, 7. Tintang, tintang. Ada orang perlu masuk. Iman Nur Hakim. Baru masuk ke? Dah masuk keluar balik ke macam mana? Iman?
Ya,
Iman? You baru masuk ke macam mana ni?
Baru masuk.
Nasib baiklah tak habis kelas lagi. Okey lah, saya anggap you datang lah. Okay So tadi ada berapa edges lupa dah? 1, 2, 3, 4, 5, 6, 7 kan? Ada 7 edges. Okay. And then degree pula, awak tengok degree, kira berapa degree. U1 ada 2 degree, U2 ada 3 degree, U5 2 degree, U6 ada 2 degree, U4 ada 3 degree, U3 ada 2 degree. By right now, you must know how to count the degree. If you don't know how to count the degree by right now ni, pergilah tu Jelumbung. Okay, V1 you have 2 degree, V2 we have 2 degree, V3 we have 3 degree, V6 2, V5 3, V4 2. Yeah, so we compare with G. G, tengok, 2 ni ada 4 degree. Degree bernilai 2 ada 4. And then degree value 3, we have 2. So you can write down like this lah. You can write down like this. Degree, we have 2 degree and then we have 4. Degree value dia 3, okay, we have 2. Okay, compare with H. H pula ada berapa vertex? 1, 2, 3, 4, 5, 6. Ada 6 vertex. Kira H pula 1, 2, 3, 4, 5, 6, 7. So ada 7 edges. So kira tadi degree dia 1, 2, 3, 4. Degree 2 ada 4. Degree 3 ada 2. So degree degree 2 we have 4. Okay, degree 3 we have 2. Compare with this invariance. Okay, 6 and 6 same. 7 and 7 same. Degree 2 4, degree 2 4. Degree 3 2, degree 3 2. Same. Semua invariant cukup syarat. Okay, follow the condition. The same number of vertices, edges and degree. So then you can make conclusion it is isomorphic. Kacang buncit saja, tak susah pun. Dalam filenya biasa 4 markah. You write down like this, 4 marks will be given for you including the conclusion. Clear Okay, tak faham lagi, don't worry, look at the next example. Tengok example yang pertama, G ni, kira dia punya vertex. 1, 2, 3, 4, 5, 6. So 6. Edges ada berapa? Kira lah. 1, 2, 3, 4, 5, 6, 7, 8, 9. So ada 9 edges. So degree, kira degree dia. This one 3, 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 this one 3. So we have degree 3 ada 6. Okay, degree 3 ada 6. Okay, so tengok tak H pula. Kira dia punya vertices. 1, 2, 3, 4, 5, 6. Okay, dia punya edges 1, 2, 3, 4, 5, 6, 7, 8, 8. Okay, 8. Ada 8 edges. Okay, tengok degree pula. Kira degree dia. Ni ada 3. This one ada 3. Ni ada 2. Ni ada 3. This one ada 3. This one degree-nya 2. Okay. So tengok kat sini. Degree bernilai 2 ada 2. So degree 2 we have 2 lah. We have 2. Degree 3 we have 4. So you write down like this. Degree 3 you have 4. Okay. So compare with all the invariant. Number of vertices, yes, same. Number of edges, not same. Number of degree, this one degree 6, this one different lah. Degree 2, 2, degree 3, 4 memang tak sama lah. So not same. So salah satu tak sama ataupun dia same not same pun dia bukan isomorphic. So this one obviously edges and degree tak sama. So meaning that you make conclusion it is not isomorphic. Kacang buncit sahaja. Okay. So isomorphic ni simple. You compare with these three invariants. Make a simple table. Okay, boleh Jelas. Ada soalan ke? Tak ada?
Tak ada kan?
Okay, yang lain-lain semua okey Saya anggap seorang wakilkan cakap pun okey lah. Okay, lambat sikit lah hari ni habis sebab saya memang kena explain. Kalau I nak rely on you by watching video tu, I'm afraid that you will not understand lah by watching the video. At least kalau this one ada two-way communication, at least you can ask me whether if you don't understand. Okay, so I want to sum up for today's lesson. Okay, the first part actually, you have learned the properties of the graph. So the important thing that you must memorize is you must know what is a vertex, what is edge, what is isolated isolated vertex, pendant vertex, how to count the degree, the meaning of the size, length, and you must know the meaning of simple graph, multigraph, pseudograph, and you must know the meaning of path, simple path, circuit, cycle, multiple edges, loop, everything you must know. Memorize it by today. Kena hafal, tak boleh tak hafal. So benda ni sangat penting. The basic part of the properties lah, you must know every term. Okay, please memorize it. Okay, kena hafal lah, nanti buat latihan. So then, the second part you have learned is the types of graph. Okay, you must know how to draw the discrete graph, complete graph, bipartite graph, complete bipartite graph, linear graph. Okay, you must know how to draw this graph. Okay, kena tahu, ambil tahu, kena tahu. Okay, the next one you must know is planarity of the graph. You must know how to redraw the graph to make it planar. If you don't know how to draw it, then you got problem lah. Don't forget, you must use the same vertices. Must connect with the same vertices. You cannot use simply change the shape of the graph. You must follow the old graph, make it the new one by removing the crossing line to become not crossing line. Tu je lah. Okay, certain line you move, not every line. Okay. But let's say if you are moving a lot of lines and your graph become planar, it is acceptable. Boleh? Tapi buat apa nak penat-penat fikirkan remove other lines. Just focus to the lines that you want to remove only. Okay, to planar graph. Okay, then the next part that you have learned is isomorphic. You must memorize isomorphic, how to determine whether the graph is isomorphic or not by comparing with all the invariants lah. You compare the number of vertices, edges and degree. If all the invariants same, so it is isomorphic. Either one is not isomorphic. Clear Tak faham, tanyalah saya, tak ada masalah pun. Okay. So today I don't give you any homework. I not giving you any online test in CDOS. Lepas ni boleh sambung tidur lah. Kalau ada kelas lain kenalah jaga. Kalau tak ada kelas lepas ni you can sambung tidur balik. I don't give you any task lah. No homework, no online test. You can relax sebab benda ni senang. Okay, tak payah sesusah pun, senang je. Nanti next time I'll give you work at online test. Online CDOS tu kena buat lah. Ada 40 soalan dalam CDOS. Nanti saya bagi masa untuk buat exercise. Okay, by today no homework, no exercise. Okay, that's all. Thank you for coming to my class. Later I will screenshot. Yes.
Nanti bagi slide ni boleh?
Boleh. Later I'll give you the screenshot. Okay, I'll give you the slide. And then I'll give you the record of this video lah. Later kalau dia siap proses. Okay class, thank you for coming to my class today. Yang tak datang hari ni, tadi saya ulang balik Sailesh Nazrul Fahmi dan Tivia dia pergi JPJ test. Okay, Sailesh Nazrul Fahmi. Kalau ada kat sini, please let me know lah. Takut dah masuk saya tak perasan. Tak ada kot, memang tak ada lah tu. Okay, sebab saya tak accept kan. Okay. So thank you for coming to my class today. Please pray for me for my birthday today supaya saya dilimpahi rahmat daripada Allah, daripada Tuhan saya. Jadi saya mendoakan you all semua sihat-sihat sampailah kita berjumpa lepas raya nanti. InsyaAllah ada rezeki terjumpa. Thank you so much. Okay, semua boleh keluar lah, boleh berambus, boleh belah. Okay, Assalamualaikum.
Terima kasih, Puan.
Waalaikumsalam.
Okay.
Happy birthday, Puan.